Hello everyone. Today we are performing exploratory data analysis using Python on the food impact on Indians dataset. The dataset contains 17,000 plus rows and 16 columns, providing insights into how different food habits influence the health and lifestyle of individuals in India. And the dataset captures details like age, region, diet type, cuisine preferences, calorie intake, and health outcomes. The dataset was obtained from this Kaggle URL, and here you can see we have person ID, age of the person, gender, region, diet type. Okay, we have primary cuisine, spice level in their food, daily calorie intake, health impact with whether it's positive, neutral, or negative, and common diseases that they have. So first of all, we will load this data in Google Colab. So here we will click on the folder view. It will start connecting with the cloud environment, and from here we will upload the file to the session. The file is loading. Remember, this file remains only for this session. So when you will close Google Colab, so this file won't be available. In the next session, you have to re-upload it. Another way is you can upload these files in your GitHub, and from there you can simply copy the CSV file. Now once the file is loaded, we can copy it, and we will first import our necessary libraries like import pandas as pd, and here we will use the file path. So let me write those code. So here we have imported pandas as pd for data processing, numpy and np for numerical ability improving it, import matplotlib.pyplot as plt for plotting basic graphs, and cbon as sns for plotting different type of graphs which are better looking. So it is simply importing that. Whenever you are performing EDA on any data set, just get a data set overview. In your data set, you have to print data.shape, data.columns, and so on, and your data will be pd.read underscore csv, and here you will just provide the file path. Okay, so this will be your data. So now data is imported. First we will print the data shape, the number of columns in the data, then we will print data.head. Okay, which will give us first 5 rows of the data. So you can see data shape is 17, 6, 86 and 16. All the columns are age, gender, region, diet type, primary cuisine, spice level, daily calories, and so on. And these are the first 5 rows. If you simply want to print it in a tabular form, so you can print it like this also without using the print function. So now you can see person ID, age, gender, region, diet type. So age, one numerical column we have, gender a categorical value, region a categorical value, diet type categorical value, primary cuisine, spice level, daily calorie intake, health impact, all are category related values. And here we have BMI also, how BMI is affecting the health score, food frequency, etc. And we have common diseases also. So here we have different type of variables. Now we will simply use data types, right? What are the different types of these data? So with your pandas object, which is data frame, if you will write d types, it will give you name of all the data types. So here you can see person ID is integer, age is integer, gender, region, diet type, primary cuisine, spice level are all object or string values, daily calorie intake integer, BMI float, etc. We can also write data.info to see how many columns have missing values and how many columns have all available values. So here you can see person ID. Total we have 17,686 values. So in age, gender, region, primary cuisine, and health impact, we have non-null values. Exercise, etc., we have non-null values. And in common diseases, we have 7,077 non-null values. That means it can be a case that in this common diseases, you can see NAN. Maybe the person does not have any disease. That's why NAN is written. And sometimes we also refer data as DF. So I will simply write DF is equal to data. So you don't get any confusion. DF or data frame is the data here. Now we'll perform some statistical analysis. For statistical analysis, we will use the describe df.describe, and we will use dot t here. So df.describes, gives you description of your data. So let me show that. So if you will do that, it will simply give you a tabular description of your data. It will take all the numerical columns and explain their descriptive statistics like mean of age is 43 in the data set, standard deviation in age is 14, minimum value of age is 18, maximum value of age is 69, and you can see minimum, first quartile, second quartile, third quartile value. Similarly, for daily calorie intake also, you can see on an average, these people are consuming 2359 calories. Okay, standard deviation between different people is 659, which is high. The minimum calorie intake a person is having is 1200, and the maximum is 3500 as per the data. And you can see their BMI also. In BMI, we don't have a big standard deviation, but here mean BMI is 29, which is good because BMI between this range is considered a good body mass index, and minimum BMI is 18 and maximum is 40. Food frequency is also something that you can see here. So food frequency is like how many times do they eat food, right? So minimum someone takes one time and maximum is someone eats the food six times, right? And our main target value, that is health score, you can see the minimum value in health score is 1, which we'll say very poor, and maximum is 100, which is very good. And you can see the mean value is 50.7. So in the data set, we have people with a health score. On an average, the health score is 50, right? So now here df.scribe.t, we will simply transpose this data and plt.figure. That means we are going to create a figure of 10, 6 size. We are going to create a heat map. A heat map will just be a graphical representation of this data, where in description we are providing mean, standard deviation, minimum, first quartile, second quartile, third quartile, maximum, and we are going to write a naught is equal to true, and the color map we are going to use is cool warm, and FMT is 0.2f for float value, and color bar is equal to true. So let's see. This will give you a simple output like this. Okay. Let's say let's make this false. So you will see that that bar is not there, right? So this is a simple way of seeing the description in form of a heat map or a graph. Here, obviously, person ID will not make any sense, but you can see in daily calorie intake, we have values between different ranges. Otherwise, in all other charts, we have most values that is in the dark blue range because it is very less. And these variables have different scales of values also. Like, for example, the calorie intake is given in thousands, right? On the other hand, food frequency and health score and other variables are just given in hundreds or maybe tens, right? So when there is too much difference, so in that case we sometimes have to use the minimum maximum scalar or log in order to bring all of them to the same scale, which we will see later. Now we have age here. Let's see how age is distributed in the data. For that, we can select the age column, df dot age. Okay, we can select this column and dot plot. We can say kind is equal to hist. Obviously, there are many other ways of plotting a histogram. This is one of them, and you can see that in the data set, most of the values that we have is either in 20 to 22 range, or we can say 67 to 70 range. We can also use sns.hist plot to create the same type of graph, and as I said, Seaborn graphs are a little bit better looking. So here you can see the bins properly, and you can see now in this case we can see clearly that the highest bins are the bins with most number of values in age are in 30 range and somewhere between 65 range. Now I'm going to show you another way. So here we are going to create a new column. That column will be called age group. So whenever you have to group your data into different bins of size what you want, so you can use pd.cut method. Okay, so it bin values into discrete intervals. Use cut when you need to segment and sort data values into bins. Okay, so we are saying we are creating 5 bins here: 0, 18, 35, 50 and 100, and we are giving them labels 0 to 18, 19 to 35, 36 to 50 and 51 plus. Okay, so this way we are using the df age column. In age column we are creating bins between these groups, and if age is between 0 to 18, it will be labeled as 0 to 18. Between 18 to 35, labeled as 19 to 35 and so on. When you will create this, then you will see that you have a new column, that is df.age group. In your data frame, if you will write df.head, then also you will see this column, right? It will be at last position, but you have the column. And if we say now, if you want to see how many, you know, people information, patient information, individual information, whatever you want to call it. So how many individuals do we have in each age group? So we will simply write dot value underscore counts to see that information, right? And we can see between 0 to 18, like, because 8 we have minimum 18 value, so we have 319 people. 36 to 50 is 5144. 19 to 35 is 5800. We have maximum people in the range of 51 plus range. Okay, now we will try to analyze it with common diseases by age. Okay, now we are going to group the data by age group, and we are going to select the common diseases column from it. Okay, so now we are going to write this, and to explain this, this particular line of code is using group by. Okay, this line of code groups the data frame df by age group column, and then finds the most common, that is mode value, within the common disease column for each age group. So we have different age groups here, 5 different age groups, and using the mode we will find the most common disease within each age group. So here dot aggregate lambda x colon, this applies a custom aggregation function to the common diseases column within each age group. The aggregate function is defined using lambda function, and x dot mode 0, inside the lambda function x represent a series containing the value of common diseases column for a specific age group, and x dot mode calculates the mode that is most frequent value of this series. Okay. 0 then selects the first element of the mode result, because in the index 0 is the first element, and if there are multiple modes with the same frequency, it only takes the first one. So basically this will simply group the common diseases by age. Okay, first we have to run this, and then I will leave the description here. You can see in all the age groups, the common disease by age is diabetes, right? Next is we are creating a function that will fill the common diseases, right? In this function, we will use row as an argument. So if pandas is null common disease, we saw that there are null values in common diseases. We will return common diseases by age, row age group, and return row common diseases. Okay, this function will return common diseases after filling it. So in common diseases we are applying this function. Okay, so now with after this function we are creating a figure and using sns.count plot. Okay, count plot shows the count of observation in each categorical bin using bars as output. So here in count plot we use X as age group, that is the bin name, hue as common diseases, which is used to color the value. The data set we are going to use is DF, and color palette is set 2. You can also use set 1, whatever you prefer. And title will be distribution of common diseases by age groups. We will simply show the graph, and now you can see we have the image. Here in the image you can see obviously in 18 bin we have less number of people, but in all other bins, as as you can see, diabetes is the most common value. We have also filled the null value, so it is also showing maximum. But then we also have hypertension. Okay, in 19 to 35, uh, unluckily we can see hypertension is the second most common disease, then cardiac arrest. When we go to ages of 51 plus, obesity becomes the second common disease. So this is distribution of common diseases by age groups before missing data imputation. Okay, this is one way of finding out. If we would not have used this group by, right, then you would have got some output like this, which was very hard to understand, right? That's why instead of using all the age values, we have simply grouped the data. So that's why grouping a data becomes very important for finding out these values. Obviously, we have done some analysis, but a simple procedure is to list your categorical columns also. So here we will select the categorical columns as from data. We will select data types, include object. So we are going to include only those columns which have object as a data type, and object dot columns we will simply select. In object dot column we will write, you know, we will simply print our categorical columns. So obviously it is simply going to select gender, region, etc. This is one way of defining all your categorical columns. And if you simply want to find out the total value counts, okay, so you can use for column in categorical columns, just print or just write here data column dot value counts, right? We are going to use the print function here. So you can see in vegetarian we have all the values. So in gender, female is 8522, male is 8422, non-binary people are 742. Similarly, in region, we can see almost all regions have equal number of people. Value counts for diet type is also, we have more vegetarian people in the data set, 9600 values. Value count of primary cuisine, like South Indian 2575, Rajasthani 2575. So here also we have almost the same number of values, but South Indian and Rajasthani are the higher values. Value count for spice level also. We can see most people prefer or eat medium spices. Low is 4000. So the least number of people or very less number of people prefer low spice. High are also there like 4506. Value count for health impact is in neutral we have 7868 people with neutral health value. Positive are 6191 like they have health impact. Negative are 3627. So similarly we can find value counts for common diseases. So obviously here this is something that we already saw, that diabetes, then obesity, then hypertension and cardiac issues are the most common type of diseases. Value counts of exercise level is people with sedentary exercises are 8754, moderate are 5364, and active are 3568. Sugar intake is there and value of salt intake is also there. But these most people prefer moderate sugar and moderate salt. Now we can also use count plot for our categorical columns. So here we will write for call in categorical columns. We are going to create a figure size of 8 comma 4 and using count plot. In count plot we already saw in y-axis we are going to put the data call means name of column, and the order that we are going to use is the value counts order like this, okay, and their index. So every time we print value underscore counts, it gives us two things, a index and a value of the index. So let's see this graph. You will see data for everything here, right? What I am going to do is I'm just going to use the third palette. So here we have count plot of gender. So let's open image in new tab. This is the count plot of gender. You can similarly you can see west region has most number of people. In diet type most data values are of people who are vegetarian. South Indian and Rajasthani are primary cuisine. In spice level medium, health impact neutral is highest, and for common diseases diabetes and obesity are at number 2. Sedentary exercise level people are mostly there, and sugar intake moderate and salt intake moderate. So you can either just see the data with values, or obviously most people will prefer a graph. Now as we did analysis of all categorical columns, we can simply create another set of numerical columns. So from here we are going to select data type, that is either int 64 or float 64, and for column in numerical columns we are going to create a figure, and we are going to plot a histogram plot, because for every single variable to see their distribution, as we did earlier in case of we created a histogram. So in Seaborn also this histogram plot can be used to create histogram of these values, right? So it one by one it will take all the numerical columns and show us its histogram. This is a simple way of plotting everything in one go. So here you can see. Obviously there is no point of seeing this person ID. We can simply delete this also. This is distribution of age, and the kernel density estimation is true. This is a simple representation of finding out like in which particular age groups can we find out most number of people. So you can see the kernel density estimation. This is distribution of daily calorie intake. We can see the daily calorie intake is a bit on the higher side. Most number of values are little bit inclined toward the higher side. We also have distribution of BMI. So around 33 range, we have highest peak there. This is distribution of food frequency. So here you can see most number of people eat 5 times as per this, right? Most count of people is in the bin, that is 5, like eating 5 times a day. And this is distribution of health score. In health score, we can see between 40 to 60, 60 to 80. So here we almost have similar values. And but people with health score of 100 are less as compared to people with health score between 0 to 20. So this is one way of analyzing your numerical data and how the values are distributed, like how many count of values we have in each bin. Definitely we have to see the impact of each variable on health score, right? So first we will create a correlation heat map of numerical values. So we will use 12,6 figure size. So a correlation matrix can be created by just taking all the numerical columns, and let me show you. So a correlation matrix, will show impact of each numerical variable on health score. So for example, just ignore person ID. So age, you can see health score, a very little, impact, 0.00. Daily calorie intake, little positive. BMI also, and food frequency also. So from this we can see age on BMI, age, daily calorie intake on food frequency. You can see the correlation between every variable, right? And this particular code will simply show it in terms of a graph. So you can see from 0 to 1, where do we have those values. We can see most of the values are between 0 to zero point 0.2 range. Now next we are going to create box plot for numerical columns grouped by a key categorical variable. So the key categorical variable we are taking is diet type. We can replace with any value. For example, Dale, we can also take common diseases here, right? So if key categorical in data column, let's see, it will create graphs for it. So here we have different box plot, percent ID by common diseases. Not going to make sense. Obviously, it is disturbing us. So what we are going to do, we will just write data dot drop person ID. Axis is equal to columns. And we will simply save the value in data. And then we will run this. Let's see what is happening here. And then we will redefine our numerical columns. Okay, because we have removed one numerical column from it. So then we have to redefine the numerical columns. And this time we will hide because it is already removed. So we will simply hide it, and now this will work. So here you can see a simple box plot. This is age by common diseases. You can see different age groups. This is daily calorie intake by common diseases. Like in cardiac arrest, you can see minimum and maximum values from where are they starting and ending. So you can see the box plot here. BMI by common diseases, food frequency, health score, etc. We also have a dedicated video for understanding what is a box plot, what is a box in whisker plot in data analysis, and how you can understand it. So that is something I will share in the description, the link, so that you can learn from that video how to read these graphs and understand it. So this is obviously the first part where we have just understood impact of our input variables on our output or target variable, that is health score. And now in the next part we will perform machine learning on this data set. So after doing EDA, when you have better understanding of the data, you can create your machine learning models and try, because it's a supervised data set, so we will try to use the supervised machine learning model to predict future outcomes. So that will be explained in the second part. So please subscribe to our channel if you want to learn more interesting things like this, exploratory data analysis. You want to learn machine learning, please subscribe to our channel. Thanks for watching this video. Please try this much. If you want the data set in this collab file, please ask in the comment section.